Hello, everybody. This is Mr. Johnson, and these are statistic notes that I'm going to be going through today. Hopefully, I'll be trying to keep it a little bit shorter since it's a Friday, and since we're starting something new. I'm actually really excited about this chapter. It's really fun, and I think it's something that is relatively easy but very useful at the same time. So we're starting um, our unit about graphs. And in statistics, you can organize data not only like with a table, which we saw last unit, but with visualizations. And there are lots of patterns and little tidbits that you can get from those things. So that's what we're going to be doing. We're going to be trying different types of graphs. We're going to do histograms, bar graphs, pie graphs, circle graphs, or whatever you want to call them, box and whisker plots, and several other types of things. And hopefully you'll be able to make an assortment of those visualizations and compare them and see, what works best for this situation. So that's where we're going to be going with this unit. Now, if you guys have all gotten your notes, it's a bigger packet. Mostly just we're trying to give you space to work, and there's a lot of numbers in here that we're going to be taking and putting into visual graphs. So let's go ahead and let's start. We're starting here with a little chart about the level of education for people who are between the ages of 25 and 34 in the United States. And you can see from the table that we have three different columns: level of education, number of people, and the percentage. And with this chapter, we're going to have some new vocabulary. And so we're going to relate this vocabulary specifically to this table. Now, in this chapter, I'm going to be using a specific word to refer to the number of people in the study. Now, this is the total number of people. So if we look, you have a column called number of people, and there is a total here at the bottom. We call this total the count. Okay, so if you had to count everybody up or add all the different categories and get the total, this number, the 39,868 people, then we call that the count. Now, the rate is the next big word that I'm going to be using a ton, and actually for the rest of the class period. So if you have to know one of these, know what rate means. And all a rate is, it's a percent of the proportion, or it's a percent slash, it could be a proportion of the count that a category represents. So what you're doing here is you're taking a category and you are comparing it to the count, the total. Okay, and by comparing in math, comparing means dividing. So we're taking the category and dividing it by the count. You could think of this as a category over the total. So usually this is a small number. So, oops, small number divided by a big number. Bigger, doesn't have to be huge. So like 2 people out of 3 say that Mr. Johnson is the coolest teacher ever. First off, that last person is probably going to fail my class. But then it's a smaller number, 2 out of 3. The count of the study would be 3, and then 2 people would have said a certain response, the correct response. Now, often they put rates off to the side, usually in percentages. So let's see. Percentages would be this column right here. Those would be rates. Percent, meaning per 100 if you had to average everything out. Excellent. So often the rates are much clearer than the counts to see what the data is really trying to show you. An example of this would be shark attacks. So let's say there are like 25 shark attacks in a year. That seems like a really high number. I mean, that's like the Sharknado coming through our classroom and killing everybody that is in there, which that's a lot. But if you compare that to the nation, like the number of people that get killed by sharks per year is statistically really, really, really small. It's less than a percent. It's like a fraction of a percent. So if you look at the regular number, 25 shark attacks, that might seem high, but if it were 0.0003%, you're obviously like, oh yeah, sharks don't really attack people. That's not really a huge concern, okay? Even though this number might be a little deceiving. 25 people have died by shark attacks. So you usually look at the rates when you're talking about information and things like that, and that's going to be percentages. Now, both of the last two columns here on this chart, so these two columns, they present the distribution of the variable. Now, they're talking about this level of education, and it tells us a little bit more information about it, but it's presenting the distribution of the variable. And it's in two different forms. It's in the number of people versus the percent. Now, the distribution of a variable tells us what values the variable takes and how often it takes those variables, or those values, excuse me. Okay, so distribution is kind of like the relationship between those things. Now, sometimes when we're making these different tables and when we're graphing things, we need to be careful because we're working with numbers and sometimes rounding errors are going to play an important role here. So if you could, I want you guys to pause the video and I want you guys to find any rounding errors that are up here with the percentages. So what you're going to have to be doing is you're going to take the category, so like for less than high school student or less than high school level of education, that would be 5,126, and you're dividing it by the count, the total, the 39,868, so 39,868. Now you're going to get a small number, a small decimal. You take that times 100 to get the percent. So hopefully if you're doing this on your calculator, at first you'll get 0.129, because if you multiply that by 100, all that does is move it 2 decimal places to the right. Okay, so this is 12.9%. I don't know if we're going to be quite on the dot with this, and I want you to go ahead and check all 5 of these. See, did we make some mistakes? Hopefully you pause the video and you look through these. Now, a lot of these are pretty close. I thought the 28.6% and the 27.5% were pretty good. Now, with the top one, I got 12.857, which that's close, but there's a little bit of a rounding error right here with the 5 makes the 8 bump up. So I don't know. I think that could have been a little bit more accurate. And the other one I thought was the 22.8. So I got 22.765. So that's 6 is bumping the 7 up a little bit. And, you know, it's fairly close. Okay, 0.8 is pretty close to 0.7. But you have to keep that in mind when you're dealing with some of these numbers. Okay, how accurate can you be? You want to try to be as accurate as possible. So that's one thing you got to look out for. Now, if you are rounding, sometimes you have the chance when you total all this up to maybe get 100.1% or 100.2. Okay, if that occurs because of rounding, that's okay. But if you're at maybe 101% or 102%, that is bad. So you want to be within like tenths of 100%. So maybe you're like 99.8. That's fine. But you want to be as close to 100% as possible. Otherwise, you're starting to skew your results. Okay, so let's go on and let's go ahead and let's talk about the first type of graph we're going to be seeing. It's a bar graph. This bar graph actually goes with the information that's right above, and it is a representation, a visual representation of what was in that chart. So you'll notice they're taking the percentages. They could have made this graph in terms of the number of people, but they chose to do percent. Now, if you're reading this, okay, the percentages here would be going over to the y-axis, this left-hand axis, and then they label each bar. Now, one thing that's important about bar graphs is that there is a space in between. Okay, that's kind of important. We're going to learn about a different type of graph. It's called a histogram. Histograms do not have a space in between. So for bar graphs, you space everything out and you have these labels at the bottom. And you can see, obviously, this is really easy to know, hey, the tallest bar, pretty close to 30% of people in this study have a level of high school education. So when we're creating this, one thing you're going to have to do is you're going to have to pick out the important information from the graph, usually the percent. It could also be the number, and then how to visually put that into a bar graph. All right, we'll have a couple projects and a little bit of homework to help you out with that. Okay, so let's go ahead and let's flip over to the next page. All right, how can we interpret different bar graphs? This is a sample problem about seatbelts, and it's asking the question, do most people wear a seatbelt? Now, each year, the National Highway and Traffic Safety Administration conducts an observational study on seatbelt use. The table below shows the percent of front seat passengers who were observed to be wearing their seatbelts in each region of the United States. Now, this happened in 2003 and 2008. What does this data tell us about seatbelt usage by front seat passengers? So you can see we have a column over here about the region, so Northeast versus Midwest versus South and West, and then the percentage wearing seatbelts in 2008 versus 2003. Now, one thing that they might be interested in doing is comparing them from point to point. So are we seeing more people wearing seatbelts, or are we seeing less people wearing seatbelts? So here's an example of a bar graph that actually has both years side by side. So one thing that's important is the key. You always want to make sure you know what you're looking at. So the lighter shade here, this is 2008 versus the darker is 2003. So this happens for each individual area. Now, if we're going back to the table and partially to the graph as well, I kind of want to know if you can pick out the individuals. Who are the individuals for this study? Now, if you're like most people, I think you're going to say, Northeast, Midwest, South, and West. Those are the individuals. But that's not quite the whole picture here. If you are really reading into the problem, that was how they grouped people. So the individuals would be the front seat passengers that they actually observed to be wearing their seatbelts, or that they asked these questions to. So it's not always going to be this left-hand column. I know they grouped them in this left-hand column by area, but each one of these is talking about and grouping the front seat passengers. Very important. So that might be something you want to write down. So like if they were standing out on the side of the road, a blue car drives by and Timmy's in the front seat, passenger seat, Timmy would be an individual. Next car drives by, it's a truck, Bob would be an individual. And then they just keep adding, adding to the list as they keep on going. Okay, they wouldn't say, in the front passenger hand seat, Northeast is the individual we're asking a question to, or South, okay? That wouldn't make sense. It's the people, the individuals riding the front seat passengers. Very nice. Now, some of the variables that are being recorded. What do we think the variables might be? And if at some point you need to pause this, if I'm going too fast, Please just pause it, not a big deal. So the variables actually are whether or not they're wearing a seatbelt. So maybe they're at a stop sign and they rolled down the window and they asked them, I see you're wearing your seatbelt. And they would say, yep, I'm wearing my seatbelt, or no, I'm not wearing my seatbelt. And then they would also record one other thing. They would record which region of the country they are in. So this would be the region, and that's actually how they split them up. So a region is how they group them. It's also a specific variable. Now, both of these, if you wanted to figure out are they categorical or quantitative, seatbelt, you figure they can say yes or no. So that would be categorical. Region, you'd think Northeast, Midwest, South, blah, blah, blah. That's also going to be categorical. So you can't really do any math with either of those. Now, what we can do some math with is the percentages, and that's why these things are so important. That's why they're really useful. So this bar graph shows us the different percentages from year to year, and it's across different regions. I want you guys to go ahead and just take a few seconds, take a minute here to describe kind of the trend. What's the pattern here overall? So one thing you might write when you're describing what you see is who has the highest percentage. Sorry, that's a bad percentage sign. Who has the highest percentage? Maybe has anyone increased? Has it been increasing over the years? Or decreasing? Not degreasing, decreasing. Yikes. Let's erase then. Decreasing. So you can go ahead and you can write kind of whatever you want. And if you guys want to discuss, I think that would be a good use of time. I'm going to keep on trucking here once you guys get that done. And we're going to talk about the next type of graph that we'll see. It's called a pie chart or a circle graph. That's another way that people refer to this. Circle graph. So I might use either of those terms. And we have an example here. This is about the level of education. Again, it's another way to represent this. And this pie chart is not using the number of people, although you could do that. It is using the percentages. Okay, that's what you have there in the labels. A lot of times with circle graphs or pie charts, they'll have a key. Okay, they'll have their different colors, and then they'll have like some college, or the high school, they'll have labels for them. And so then you'd be able to see what is what. Okay, now I know a lot of programs that create circle graphs, they will start here at the top and they will rotate their way around the circle. Okay, so it's hard to tell sometimes with the colors, but you usually know that they start at the top and kind of work their way around. That's kind of the typical process. So comparing these two, okay, you can see, and actually it would be comparing the graph all the way back up here with these colors. Okay, the biggest one was high school graduates, and some college was pretty darn close. So going back, taking a while here. High school graduates and some college, the percentages are close, but then the area that is made by these two triangles, these wedge shapes, is pretty darn close too. We call this, just a little vocabulary, this is the sector. So that is a sector of a circle graph or a pie chart. this. That is called the central angle. So this is our central angle. And we are going to need to find this central angle in order to create these. So how do we make pie charts? The first thing that you have to do in order to find the central angle, because all of these angles should add up to 360 degrees. So they should add to 360 degrees. That's really important. But what we do is we take a part, okay, and divide it by the whole. We're taking the category and dividing it by the count if we're using our vocabulary from today. So you should have a smaller number divided by a bigger number. Now, this is going to get us, in the end, it will get us a percent. Get us a percentage. Now, we don't want a percentage. I mean, these are percentages. These don't talk about degrees of the circle. This is not 28.6 degrees by any means. Okay, right there. That is more than 90. Just like this is more than 90, okay? So we can't use this right away. What we have to do is we take this percentage times 360. So usually this will be a decimal. You just multiply by 360 and that gets your central angle measure. So this process, really it's included right here. That's how you make a pie chart. Now we have how many different sectors? We have 5 different sectors. So we're going to have to do this process right here 5 different times. Okay, and as we are building our pie graph, so we might do it the first time and get a teeny tiny sector like this. We might do it the second time and maybe get a larger sector like that. And as we are working, okay, we'll start here and we have to keep adding the sectors together. So this next sector would be here and you'd add and it would end up there. What you do not do is you do not mark a sector and then start back over and mark another sector. Okay, so they do not overlap like this. That is bad. No overlap. Okay, you have to start from where you left off. So at this point, you'll start. Okay, so say that is 20 degrees. You will start over and then you'll add your 80 degrees. So here we have 80 degrees and 20 degrees. You do 20 degrees and then you add 80 degrees and that lands you at 100 degrees, and you just keep on working your way around the circle, building your circle graph, your pie chart. So there are some obvious benefits and differences between bar graphs and pie charts, and this is the last thing that we're going to cover today. So in a bar graph, the height shows the value. So the higher that bar graph was, the higher the percentage. We saw that with the education and we saw that with the seatbelts. Now this is compared to a pie chart where the angle shows the value. Okay, so little picture here, a little guy versus a big guy. Here, a little sector versus a big sector. And that's supposed to be the outside of the circle. I'm not a very good circle drawer. So that's the first big difference. Now, the second is that bar graphs can compare separate parts. Okay, so you can compare populations or regions, like specifically up top, we compare different regions. So So if you were doing an interview, you could compare different populations or things like that. Now, if we compare all the parts in a circle graph, it doesn't mean exactly the same thing. All the different parts here in a circle graph, they add up to the whole, so they equal the whole population. So the parts all go together and they create a whole. In bar graphs, that's not necessarily the case. It can be, but you can compare those separate parts. Doesn't have to make a whole. Now, bar graphs are usually good for quantitative variables, so they're good for numbers and things like that. So, good for quantitative variables. And then pie charts are actually good for quantitative variables as well. So this is actually a common thing that they have. So they're both good for quantitative variables. So that actually goes across both types of graphs. So if you need to go back and watch any of this, that might be a good thing to do. And possibly with the rest of your class period, you might want to look into some of the next things that we're going to be covering on Monday when I get back. Dot plots is going to be one, which are very similar to bar graphs. They're also very similar to histograms. We're going to be doing some projects here with dot plots. The second type is called a stem plot. You might have heard it called a stem and leaf plot, but we're going to be organizing some data from that. And I think that is it. We're going to talk a little bit about histograms and things like that, and then distributions to finish us off with these set of notes. So one other thing that we're going to be doing, just to give you a little heads up, is a big project with restaurants and comparing nutritional values. So something you might want to think about over the weekend, if you're not looking into these different types of graphs, is maybe look at some of your favorite restaurants and think, what might I want to compare if I'm going to be comparing restaurants? Which restaurants would I want to use? So that's kind of a heads up on where we're going. I'm really excited, and I will see you guys in a couple of days. Have a good one.